This is a conservation of momentum problem. We have two balls of clay that stick together and travel off as one blob of clay after the collision. So we'll do a before and after. And this is called a perfectly inelastic collision because they stick together. So the 20-gram ball we'll have traveling east, that's to the right at 2 meters per second. And the 30-gram ball is traveling south of west at 1 meter per second. And this would be 30 degrees. And after the collision, they mush together as one 50-gram blob. And they travel, now we're not sure whether they travel down and to the right or down and to the left. But let's just assume they travel down and to the right with some final momentum Pf. And we'll call the angle between the horizontal and Pf theta. Now momentum is conserved, and momentum is a vector quantity. And so the sum of the vectors of momentum before must equal the sum of the vector final momentum. So I'm going to draw a triangle, and we're going to use that triangle geometry to find the final momentum. So for the 20-gram ball, I'll have its initial momentum to the right, that's P1. The 30-gram ball's momentum is down and to the left, call that one P2. And the sum of those two momenta must equal the final momentum Pf, where the angle here is 30 degrees and the angle here is theta. So we can simply apply the cosine law and the sine law to find that final momentum Pf. So P1 is equal to 20 grams times 2 meters per second. And I'm just going to leave that in gram meters per second. And P2 is equal to 30 grams times 1 meter per second. And so that's equal to 30 gram meters per second. And these are actually just magnitudes. So these are the lengths of the sides of that triangle. So this top one is 40. And this one is 30. Now, in order to find Pf, we can apply the cosine law. So the magnitude of Pf squared would be the magnitude of P1 squared plus P2 squared minus 2P1 P2 cos 30 degrees. So putting those values into this cosine law, we have 40 squared plus 30 squared minus 2 times 40 times 30 cos of 30 degrees. And we get the magnitude of Pf to be 20.5 gram meters per second. So that's the magnitude of the final momentum. To get the magnitude of the final velocity, note that momentum is mass times velocity, and so velocity is that momentum over the total mass of the blob. So it's the 20.5 over 50 grams to give a final velocity for the blob of 0.41 meters per second. Now we go back to the triangle to find theta, and we apply the sine law. So we have that the sine of theta over P2 must be the sine of 30 over Pf, or the sine of theta is equal to P2 times sine 30 over Pf. And that gives us an angle of 47 degrees, and it is south of east. So the final velocity of the bob is equal to 0.41 meters per second at 47 degrees south of east.